Okay, so I had mentioned earlier that we could do the 3D terrain model cleanup using these two files, which is the .obj and .mtl. I'd never worked with these files before, but this is what comes with the downloadable complete full asset package from the photogrammetry exercise. I'm using WebODM as I'd mentioned earlier. But since this is not working well, let me just show you how it looks in Cloud Compare. Cloud Compare, this is how it looks. It is not useful for me because I want to be able to see the actual colors as well in the point cloud. And so I'm going to now take this opportunity to show you how I upload and do the photogrammetry process as well. So I've got this is the first step. I transfer the pictures into this portable SSD, and then I will transfer the folder to my local computer, and then I'll upload it onto the photogrammetry software from that, because this just makes it much more faster in the upload. Otherwise, if you're uploading directly from your SSD, it can take some time. And so I'm just going to get the RGB pictures, just drag it and drop it to my computer. And I have a tool which separates the multispectral and RGB pictures anyway. Let me just close the drive. As we can see, we have about 136 images, and I will just upload this into WebODM now. In WebODM, I just ran out of my plan, so I'm going to see if we can do something. Hopefully, we can at least get the outputs. Let's just save it, give it a name, select the images. I just showed you I transferred it from the SSD, and so let me just select that. Come here, select all of the images, and I'm going to go with open. And then here, this is WebODM, by the way. So here it shows you the path of the pictures taken. This is not multispectral, this is RGB. So I'm just going to go for 3D model actually, because that's what we need for our particular task. If I was to get the orthophoto, which is the RGB map, and the digital terrain model and the digital surface model, I would select this option. If I was uploading and processing the multispectral, I would select this option, where the main output is just a multispectral orthophoto. We don't take the digital terrain model and the digital surface model from there. But now we're going to use this 3D model because we're looking for the .las file that works well with Cloud Compare and allows you to do the cleanup. The .obj and .mtl files, as seen for this camera-based photogrammetry approach as opposed to LiDAR aerial surveying. The LAS file you get from the LiDAR as well, but here the LAS file has been simulated based on geometry and triangulation of multiple photographs having a common pixel, overlapping images. So that's how it does that geometry. And so yes, I'm just going to review and start processing. It's going to upload the images first. There's about 1.5 GB of images, and then it will process it, and hopefully I can quickly download it and use this free instance of WebODM. Okay, so it's done. The job is done, and I'm going to click on map. Inside map, we have the option to view the 3D model. And in there, we're going to first explore this. As you can see, it's a colored 3D model. And this is what we need to further process in Cloud Compare so that we can simulate the actual ground in a much more optimized and accurate fashion. So for that, we are going to click the download button, which is beside metric at the bottom. There it is. And I'm going to go and click on point cloud. And the format is LAS. We're going to leave the CRS as it is and click download. After that's done, we'll be importing it into Cloud Compare and then take it further. Okay.